Hey everybody, in this video I'm going to show you how we graph the arcsine function and where it comes from. So up at the top, what we have is we have the graph of y equals sine of x. Now arcsine is the inverse of this function. And it is a function because, well, it passes the vertical line test. If I draw a vertical line, it's only going to cross this graph at most one point. Now the way we come up with arcsine is the idea of we're going to draw the inverse. And so down here, what I'm going to do is I'm going to graph x equals sine of y. Now the only thing that happened is that the x and the y values, they just traded places, which is what an inverse does. So I'm going to use the original sine graph, and I'm just going to take the x and y values and trade places with them. And so that's why these axes are shaped the way they are, because normally we expect pi and pi over 2 and 3 pi over 2 and 2 pi to be on the x-axis, but here they're on the y-axis because we're plotting the inverse. So the first point on the sine is negative pi over 2, negative 1, right here. Well, now it's going to be negative 1, negative pi over 2. So that point is way down here at the bottom. So that's our first point on this graph. Can't call it a function yet because it may not be. So then our next point, sine, goes through 0, 0. So the inverse also goes through 0, 0. So we plot that point. Then the next sine goes through pi over 2, comma 1. So the inverse is 1, comma pi over 2. And then for sine, it goes through pi, comma 0. Which when we exchange places for x and y, it becomes 0, comma pi. And then 3 pi over 2, negative 1 is the next point right here. And so that's going to be negative 1, positive 3 pi over 2 right there. And then finally, sine goes through 2 pi, comma 0. So that means it's going to go through 0, comma 2 pi. And so if we look at this graph, what we have is we have this kind of shape. And so it curves in this direction. Now it kind of looks like a sine graph. It just goes back and forth in the other way. It just goes up and down as it waves back and forth. The problem is this is not a function. And so when we talk about arcsine, this is actually not the graph, because we talk about arcsine as a function. And so in order for this to be a function, what we have to do is we have to basically take it just a snippet of this graph in order for it to be a function. And so what we do is we just take this piece of our graph and say, that's it. If we were to take any more of this graph, it would not be a function. And so what we have here is the graph of y equals arcsine of x. And we can even go so far as to say that this is a function, that this does pass the vertical line test. Whereas this, notice I didn't write it with function notation because it doesn't pass the vertical line test. But this does. So this is our function for arcsine. And we get it by taking the sine graph and switching the x and y values. And we only take this snippet of it. So, since it's a function, we can state what its domain and range is. So the domain goes from negative 1 to positive 1. And then the range goes from negative pi over 2 over here to pi over 2. And so that's the only piece of the function for arcsine that we will ever see when we graph it. If we tried to graph and see any more, it would fail to be a function. Thanks for watching. Hope this helps. If you want to see more videos like this, click the subscribe button. If you have suggestions or other problems you want to see worked out, click the type a comment below. Thanks so much for watching. And remember, the best way to understand something is to do it.